So what happens if we have an equation where we have an absolute value on each side of the equation? Well, if whatever this value evaluates to equals whatever this side evaluates to, then when you take the absolute value, they're still going to equal. So it appears that we get one solution when 2x minus 5 is equal to 3x plus 10. So we can go through and solve this. So subtract 2x from both sides, we get negative 5 equals x plus 10. Subtract 10 from both sides and we get negative 15 equals x. So let's see what happens when we plug this into our equation. So 2 times negative 15 would be negative 30, minus 5 would be negative 35. So when we take the absolute value, on this side we would get 35. Over here, 3 times negative 15 would be negative 45, plus 10 would give us negative 35, and the absolute value, this would become 35. So x equals negative 15 is a valid solution. Likewise, if whatever 2x minus 5 evaluates to is negative 1 times what 3x plus 10 evaluates to, for instance, you might get 10 inside this parentheses and negative 10 inside this parentheses, but when you take the absolute value, your equation will say 10 equals 10. So we get the other solution by setting the left side equal to the right side times negative 1 to get negative 3x minus 10. So then we add 3x to both sides to get 5x minus 5 equals negative 10. Add 5 to both sides, 5x equals negative 5. Divide both sides by 5, we get x equals negative 1. And let's see what happens when we plug that in. So 2 times negative 1 would be negative 2. Minus 5 would be negative 7. When we take the absolute value of negative 7, we would get 7. And over here, 3 times negative 1 would be negative 3. Plus 10 would be 7. In absolute value, that would be 7. And there we have our two solutions to the equation.